Hello ladies and gentlemen, in today's chemistry tutorial brought to you by Ujuzi Africa, we will be looking at atoms, elements, compounds and mixtures. An atom is the basic unit of matter. It means when you break down matter into its most basic component, all you'll find is an atom. Now, if you check your textbooks for a diagram of an atom, you'll see that all it consists is a nucleus that is surrounded by negatively charged electrons. If we look deeper into the nucleus of an atom, we will see that it consists of neutrons and protons. Here's the interesting thing and how atoms are linked to elements. The number of protons in the nucleus of an atom is what we call the atomic number. And this atomic number tells us the chemical element that atom belongs to. So, if you look at your periodic table, for example, when we find an atom that only has one proton in its nucleus, in other words, when it has an atomic number of 1, we say that that atom belongs to the element hydrogen. When we see an atom that has an atomic number of 2, i.e. 2 protons in its nucleus, then we know that that atom belongs to the element helium. So you can have different atoms of, you can have atoms of different types depending on their atomic number. And these atoms give us the elements that we know today that are very common in the universe and in the world we live in today. So if I find an atom with an atomic number of 8, then I know that that belongs to oxygen. If I find an atom with an atomic number of 20, then I know that that belongs to calcium. Now, an element consists of only one kind of atom. You cannot have, an element will only consist of the atom, the hydrogen element will only consist of an atom with an atomic number 2. The oxygen element will only consist of atoms with atomic number of 8. That is, they will only have 8 protons in their nucleus. The atom is the element is the purest. Is the purest substance, a homogeneous material that you can find. It cannot be broken down into any other substance, which is what I mean by pure. So if I took oxygen, for example, I could not physically or chemically break that down into any other substance. It is not a combination of 2 or more substances. It's just the one. But if I took 2 or more elements and I chemically combine them together such that they are chemically bound, then I have what is called a compound. So for example, if I combined hydrogen and if I combined 2 atoms of hydrogen and 1 atom of oxygen, I would have water. Now, the compound will always contain the same ratio of its component atoms, which means the compound water will always have 2 atoms of hydrogen and 1 atom of oxygen. If you took any other compound, it will always consist of the same ratio of its component atoms anywhere. Another interesting feature is the new compound that was formed from the combination of 2 or more elements will always have or will have properties that are different from the element that combined to give you that new compound. So hydrogen has its own chemical properties. Oxygen has different chemical properties, both combined to give you a compound, water, with completely different chemical properties as well. Very different from oxygen, very different from hydrogen. Now, if I was to take 2 or more different elements and I physically combine them, not chemically, but just physically, such that they're just physically intermingled with each other, I have what is called a mixture. An interesting difference between compounds and mixtures is a compound can be chemically only chemically, not physically, only chemically broken down into its component elements. So I could take water and break it down into hydrogen and oxygen, chemically but not physically. A mixture, on the other hand, consists of two or more different elements intermingled physically, not chemically but physically, and can be separated into its components physically. So if I took two or more elements and I combined them physically to form a mixture, I cannot use a chemical process to break it down into its various components, because in the first place the mixture was only produced physically, not chemically. Likewise for a compound, because the elements involved in the combination are chemically bound, I cannot use a physical process to separate the compound into its different component elements. Now, another interesting feature, if you remember, I told you that compounds, when produced, have different properties from its component elements. So, for example, I talked about water having different properties from hydrogen and oxygen. Well, mixtures more often than not, retain many of the properties of its component elements that were used to produce the mixture in the first place. We can divide mixtures into two different kinds, and that would be heterogeneous mixtures and homogeneous mixtures. Heterogeneous mixtures are when you take two or more elements together and you physically combine them, but the combination is not evenly spread throughout the mixture. So in one area you'll have more of a kind of element somewhere than the other, and it's lighter there, it's darker there. You have it's not even. The mixture is not even. Then in that instance we have what is called the heterogeneous mixture. Now, when that happens, well, to begin with, I'll give you an example. An example of a heterogeneous mixture will be rocks. When you take a huge lump of rock, you'll find, the elements formed to give that rock. You have one kind of element predominant in one area of the rock and less predominant in the other. You'll have it lighter in one area and darker in one area, softer, harder in one area than it is in another area. Another example will be oil and water. When you mix oil and water together, they're not chemically combined, they're just physically intermingled with each other, and you have more water in one area than you would oil, and you'd have more oil in one area than you would water. In that case, we have what is called the heterogeneous mixture. Now, homogeneous mixtures are completely different from heterogeneous mixtures. And homogeneous mixtures, when you mix two or more elements together, the substances, or two or more elements or compounds together, the substances are evenly spread together. For example, would be blood. Blood is a physical mixture of elements and compounds. But from the looks of it's all evenly distributed. You're not having it's the same ratio of elements or compound everywhere else. It's not it's not, well, it's evenly distributed, let's put it that way. An example, like I said, was blood, or soft drinks, for example, or glass, or seawater. The mixtures, the compounds involved in making the homogeneous mixtures are evenly distributed throughout. You won't find one area being lighter than the other, or having more of a compound or an element in one area than in the other, as compared to you would with where you mix oil and water. So, ladies and gentlemen, that is a brief explanation of atoms, elements, compounds, and mixtures. Please feel free to compare to your textbooks, to your notebooks, or even what your teachers taught you in class. But at least this is just to give you a brief summary and overview of chemistry, and with this we'll begin to build up as we go into various topics in the syllabus as well. Thank you for your time, and I will see you or speak to you soon. Take care.